A herd of elephants stands in the shade of an acacia tree in southern Kenya. A truck approaches on the dirt road, engine rattling, dust rising behind it. The matriarch lifts her head, checks the wind, and goes back to feeding. A few minutes later, a different group of people walks the same stretch of road on foot, dressed in red cloth, moving in single file. The matriarch's ears flare out. She lets out a low rumble. Within seconds, the entire herd is moving away, calves tucked between the adults, the whole group retreating at a pace that looks almost rehearsed. Same road, same time of day. Two completely different reactions to two groups of people who, to most of us, would look equally harmless from a distance. The elephants did not react to humans in general. They reacted to a specific kind of human, and they got it right almost every time. That single fact breaks an assumption most people carry around without ever examining it, that animals fear us the way they fear fire, as one undifferentiated threat. If that were true, every human silhouette should trigger the same response. It does not. Somewhere in that elephant's memory is a filing system precise enough to separate a farmer from a herder, a tourist from a hunter, based on almost nothing. Cloth color, language, gait. The question this raises is bigger than elephants. If one species can sort humans into categories of actual danger, how many others are doing the same thing right under our noses? And what exactly are they picking up on that we can't see ourselves doing? If you're enjoying this story so far, don't forget to hit the like button and subscribe. Drop a comment telling me where in the world you're watching from. I love hearing from you. The elephant study is real, and it is more specific than it sounds. In 2006, biologist Karen McComb and her team at the University of Sussex ran a set of experiments in Amboseli National Park. They played recorded voices through hidden speakers near elephant family groups, some speaking Maasai, a pastoralist community whose young men occasionally spear elephants during cattle disputes, and some speaking Kamba, a farming community that rarely comes into conflict with elephants at all. The elephants that heard Maasai voices bunched together and moved away within seconds. The elephants that heard Kamba voices, speaking the same volume, the same distance, barely reacted. Then the researchers tried something stranger. They played Maasai voices digitally altered to sound like women or young boys, groups that are almost never involved in spearing elephants. The fear response dropped sharply. The elephants were not responding to a language. They were responding to the demographic most likely to be carrying a spear. Here is what makes that finding land differently once you sit with it. Nobody taught those elephants which voices belonged to which group. There was no lesson, no signal from a parent explaining the difference between a farmer and a herder. Each animal built that distinction out of accumulated experience, watching what happened to elephants near certain people and not others, over years, sometimes over decades, because elephant memory runs that long. A herd that lost a member to a Maasai spear carries that information forward, and it gets passed down through the group, the way a family passes down a story, except the story is written in behavior instead of words. Elephants are not alone in this. Crows do something almost identical, on a much shorter timescale. In 2006, wildlife biologist John Marsluff at the University of Washington captured and banded wild crows while wearing a specific rubber caveman mask. He released the birds unharmed. For years afterward, any researcher who put on that same mask, regardless of who was wearing it or where they walked on campus, got mobbed and scolded by crows. Crows who wore a different, neutral mask were ignored completely. The birds had linked one specific human face to danger and held on to that association for years. Some studies suggest well over a decade. They taught it to crows who had never even been captured. Young birds that hatched after the original incident learned to scold the caveman mask from watching their parents do it, never having experienced the capture themselves. That detail is the one worth sitting with. The threat wasn't humans in general. It was one face, memorized precisely enough to be picked out of a crowd and passed down like inherited knowledge. A crow can hold a grudge against a specific human silhouette longer than most people remember a stranger's face from a single encounter. Marsluff later expanded the experiment across the city of Seattle, having volunteers wear the same threatening mask in neighborhoods the original crows had never visited. Within a few years, crows in those neighborhoods were scolding the mask too, passed along by birds that migrated, by offspring, by whatever informal network exists among a species known to gather in the hundreds to watch and remember what happens to one of their own. And if that sounds almost too precise to be believable, consider what happens when animals have to sort danger not by face, but by behavior, in real time, with no name or mask to go on. Elk in Yellowstone, and in hunted landscapes across the American West, show a version of this that has nothing to do with recognizing anyone individually. Researchers tracking elk during hunting season versus the rest of the year found the animals shifting their entire daily rhythm. During hunting season, elk moved at night and hid in dense cover during daylight, the hours when hunters are on the landscape. Once the season closed, the same herds relaxed back into daytime grazing within days. Nobody told the elk when the season opened. What changed was the pattern of human movement itself. More vehicles parked at trailheads, more people walking slowly and quietly through the tree line instead of following the usual hiking paths, a different rhythm to the noise. The elk were not reading calendars. They were reading behavior, and specifically, they were reading the difference between a human walking with purpose toward a destination and a human moving slowly, scanning, stopping, exactly the pattern of someone hunting. Wolves show the same split, and it comes with numbers attached. Researchers studying wolf packs in areas where hunting is legal versus areas where wolves are fully protected have found measurable differences in how close the animals allow humans to approach before fleeing. In hunted zones, wolves typically bolt at distances far greater than in protected zones, sometimes triggering flight before a person is even aware the pack is nearby. Move the same species into a national park where hunting has been banned for generations, and that flight distance shrinks dramatically, to the point where wolves have been documented resting in plain sight a few hundred meters from hiking trails. The genetics did not change between those two populations. The local history of human behavior did, and the wolves adjusted their entire risk calculation to match it, generation after generation, den after den, without anyone in either population ever being told the rules. Domestic dogs carry a version of this ability that most owners never think to name. Studies out of Hungary, led by researchers including Adam Miklosi and colleagues at Eötvös Loránd University, found that dogs respond differently to human voices carrying angry emotional tone than to the same words spoken calmly, even in a language the dog has never heard before. The dog is not translating vocabulary. It is reading pitch, speed, and tension, the acoustic fingerprint of a person who might be a threat versus one who is not, and making that call almost instantly, the same skill running underneath every dog that goes stiff the moment a stranger raises their voice in another room. That distinction, purposeful movement versus searching movement, shows up again and again once you start looking for it. Prairie dogs, studied for decades by biologist Karen McComb, produce alarm calls specific enough to encode the size, shape, and even the color of clothing worn by an approaching human. Slobodchikov's team recorded prairie dog calls in response to different people walking through their colonies and found the calls changed depending on what the person was wearing, not randomly, but consistently, the same call for the same shirt color across repeated trials. A human walking through in blue got a different call than the same human walking through in yellow. The animals were not identifying humans as a category. They were building a running description, almost a police sketch, updated with every pass. If you're hooked on this story, make sure to subscribe and turn on notifications so you never miss an upload. Your support means everything and helps me bring you more emotional stories like this one. None of this means animals understand human intention the way we do, and that is where the story gets complicated instead of comforting. What these species are running is closer to pattern matching than judgment. An elephant does not know what a spear is for. It knows that a certain combination of voice, cloth, and posture has, historically, preceded pain. A crow does not understand revenge or grudges. It has a face flagged as dangerous, filed away, and it acts on that flag automatically, even decades later, even against a person who has never done anything except wear the wrong mask. The system works because the world rewards it often enough. It also fails constantly in ways that go unnoticed, because the failures don't make for dramatic footage. Baboon troops studied in South Africa's Cape Peninsula show both sides of this at once. Troops that live near tourist areas learn quickly that people carrying bags and walking on marked trails rarely pose a threat, and some troops become bold enough to raid vehicles and homes for food, a behavior that gets a huge number of them killed by property owners and wildlife managers every year. The same pattern reading ability that lets a baboon distinguish a hiker from a farmer with a shotgun also convinces it, wrongly, that a car full of groceries is safe territory. The skill is real. It is also blunt enough to misfire in exactly the situations where getting it wrong costs the most. The same pattern turns up in African savanna baboons, watched over years by researchers tracking troop responses to armed anti-poaching patrols versus unarmed research teams walking the same routes. Troops that had lost members to poachers grew visibly agitated at the sight of a rifle silhouette, scattering into trees long before the patrol came close, while showing almost no reaction to researchers carrying cameras and clipboards along an identical path. The shape of the object being carried mattered more than the presence of a human at all. A long, straight object held at a certain angle across the body appears to trip something ancient, something that does not require the baboon to know what a rifle actually does, only that objects carried that way have, often enough, preceded gunfire. That is the complication sitting underneath the whole premise. These animals are not detecting danger the way a smoke alarm detects fire, reliably and without prejudice. They are running probability, built from whatever sample of encounters their species or their individual life happen to provide. An elephant population that has never been speared by anyone learns nothing about spear-carrying postures, no matter how threatening those postures might actually be. A crow that was never caught by anyone never develops the caveman mask response at all. The system is powerful, but it is also entirely local, built from a specific history in a specific place, which means an animal moved somewhere new can be catastrophically wrong about who to trust, at least until it accumulates a fresh set of data, sometimes at a fatal cost. Urban coyotes add another layer to that same problem. Wildlife biologist Stan Gert, who has tracked coyote populations through Chicago for more than 2 decades, found that coyotes living deep inside the city rarely attack pets or approach people directly, largely because the ones bold enough to try that generally get removed or killed, leaving behind a population shaped by exactly the pressure that made them cautious in the first place. But that same caution collapses fast once coyotes are fed, deliberately or by accident, through unsecured trash or people tossing food from a car window. Within a handful of encounters, an animal that avoided direct contact for its entire life will approach a stranger without hesitation, because the pattern it is running has been overwritten by new data that says humans reliably produce food near this specific spot. The wariness was never a fixed trait. It was a running average, and a running average can be dragged in either direction faster than most people expect. This is where the deeper layer of the story sits, and it changes how the whole thing should be read. What looks like animals sensing danger is really animals reading us, constantly, and building a statistical model out of what they observe, updated across a single lifetime for some species and across generations for others. The elephants of Amboseli are not more spiritually attuned than elephants anywhere else. They live in a place where the difference between a Maasai herder and a Kamba farmer has mattered, repeatedly, for a very long time, and that history got encoded into behavior. Move those same elephants to a region where no such history exists, and the ability to sort humans that precisely simply would not be there. The skill is not a gift, it is a record. There is something uncomfortable in that, for us specifically. Every one of these species is running a version of the same question about every human who walks near them. Not who are you, but what does someone who looks and moves like you usually do next? Slow, deliberate steps, a certain stillness, a body oriented directly toward them rather than moving past. These are the signals that repeatedly precede harm across enough species and enough separate studies that it starts to look less like coincidence and more like a shared grammar, one written by predation itself rather than by any single species learning it independently. A hunting posture reads as a hunting posture whether the observer is an elk, a baboon, or a deer that has never met a human with a rifle in its life. Something about the shape of a stalking approach seems to be legible across an enormous range of nervous systems, ours included. If you think about how instantly you notice someone walking too slowly and too close behind you at night, that last point deserves a moment, because it runs in both directions. Humans do exactly what elephants and crows do, just faster and with less credit given to the process. Nobody teaches a person to feel uneasy about a stranger standing too still in a parking garage, watching without moving toward anything in particular. Nobody has to explain why a person crossing the street to walk closer to a lit storefront feels different from a person walking briskly with their eyes fixed on a destination. That reading happens below language, the same way it happens for a prairie dog clocking the color of an approaching shirt. We tend to treat human intuition about danger as instinct and animal intuition about danger as instinct, in a much shallower sense, unconscious, mechanical, beneath real understanding. The elephant data, the crow data, and the elk data suggest that gap might be smaller than it feels. What we call a gut feeling about a stranger, and what an elk does when it shifts to nighttime grazing during hunting season, may be running on the same underlying architecture, sorting behavior into safe and unsafe categories built entirely from accumulated pattern, not from any deeper knowledge of who a person really is. Think about how quickly your own body makes that same call before your mind catches up. A stranger falls into step behind you, and your pace changes before you have consciously decided anything is wrong. Someone stands a little too close in an elevator, and you find yourself angled toward the door without remembering the decision to move. That reaction is not learned in any classroom, and most people could not explain the exact cues that triggered it if you asked them directly afterward. It runs on the same kind of accumulated pattern an elephant uses to sort a herder from a farmer, built from a lifetime of small encounters that mostly ended fine, with a handful of exceptions sharp enough to leave a permanent mark on the filing system. We just rarely stop to notice that the mechanism doing the sorting is not fundamentally different from the one running inside a crow watching a rubber mask cross a parking lot. So, the next time you see a photograph of wild elephants standing calm a few hundred feet from a group of tourists, or a deer that barely lifts its head as hikers pass on a trail, remember that calm is not innocence, and it is not trust in the way we usually mean the word. It is a conclusion, drawn from thousands of prior data points, collected by that animal or by the animals that raised it, about what that particular kind of human, moving in that particular way, tends to do next. Change the posture, change the pace, change the direction of the gaze, and the same animal that ignored you completely will be gone before you finish taking a step toward it. They were never unaware of you. They had simply already run the numbers and decided, for now, that you were not the kind of danger worth moving for. That calculation resets constantly, for every species doing it, including us. The elephant that ignores a farmer today will remember a single bad encounter for the rest of its life. The crow that scolds a mask will eventually pass that memory to offspring who never met the original threat at all. Somewhere between instinct and memory sits a running tally that decides, moment to moment, who gets to walk close and who gets a warning call from the treetops. And the strange comfort in that is knowing every creature sharing this planet with us is running some version of the same quiet arithmetic, watching, filing, and waiting to see what we do next. Thank you so much for watching until the end. If you loved this story, check out the other videos on your screen now. I think you'll really enjoy them. And don't forget to subscribe if you haven't already. See you in the next story.